Good morning and welcome to the ridiculously early J morning show. My name is Michael, I'm your host, and today we are resuming work on jprez, the presentation tool written in J for J, and hopefully for other languages in the future. So I moved a bunch of things into the sprint that had to do with just adding key bindings, but make key bindings table driven. This is what I'm thinking about today. So I'm going to move that into our sprint because I think I've got a good idea what I want to do here. So I actually, over the weekend, I'm preparing for a game jam at the moment as I'm filming this. So I published this gridpad. So I've made some videos about a sprite editor in the past. One about basic animation in J, one about just a sprite editor. It is that you have this little sprite editor and you can zoom in on the sprites and have a little sprite sheet and so on. So this is all written in J. I picked it up again because I'm doing this game jam this weekend. So you might have seen my stream yesterday where I was working in K to make a small game. If not, check it out, it's cool. I was using OK and Ike to make a little start on a little game in K, and that's what I'll be doing this weekend. But anyway, the point of that is that this image right here is actually just in the source code. It's this right here. And so I'm basically parsing this table. The idea being that this symbol right here means explicit definition. And so what it says is this is a noun, and then where does it come from? And it can either be a string or it can be the number 0, in which case the following lines are all just red. So this is like a multi-line string. If this is a 3 or 4 or a 2 or something like that, then those codes all indicate other parts of speech. So 0 is a noun, meaning a string of characters. And so this whole thing gets parsed as one long string with line feeds and new lines and whatever. And then when it encounters a close paren alone on a line, that indicates the end of the string. And so this allows you to embed like any kind of language or table or whatever that you want into your J code. You can put comments in there. You can put strings of various types, any like data that you want to work with. And then the string itself gets returned as the value of that function or that verb, or rather this is the verb, and then this is the argument to the verb. And so that's a complete J sentence. And so this executes, and then the result is then passed to whatever else is on the left-hand side of the line. That means that you can feed these into a parser and do something with them, and you can put like configuration code or whatever inside these little blocks. So I've done that a couple times in the past, and it just seems like a nice way to organize like tables and like data-driven code in J. And so that's what I'm thinking about for tables, specifically to make the key bindings table driven. So jprez is the new file that you use to go into jprez in TangentStorm jprez on GitHub. So if you check this out, this is where I'm working. And this file, jprez, is now the main file. Somewhere in here, we have some examples of where I'd like to use this concept of table-driven code. One of them is right here. So this is the screen setup where I'm defining a bunch of widgets. So we have the list widget, the commands widget, the LED widget, and they all have the same thing. They have a width, a height, and they have X and Y. And so I'd like to turn that into a table, I think. And then we got some commands for like extensions to individual widgets where we're overriding things or customizing them. But then we have these key mode things. So key mode is a verb that takes the base locale, the namespace in which this thing is running, and it modifies the path that it uses to look up words. And so we capture the lookup path at the start of the program. And then every time we call key mode, the right argument is called Y. And so we're putting it at the front of this. So basically add a frontmost item in the lookup path. And that way, as we switch from mode to mode, we can have different key bindings in different namespaces. So that, for example, when this is highlighted, the N and peak next and previous keys move up and down. Whereas if I press tab and now this REPL has the focus, then obviously this is a read eval print loop, so you're typing commands in, so you want to be able to type the letters N and P and J and K, and so those keys are bound to different activities depending on which widget is active. And then there's the intent that right now, for example, if you press Control S to save, nothing happens. So you have to tab back to this place to save. So that's not what we want, obviously. You don't want to think you've saved your work and then not save your work. Of course, that's one of the items to change. But the reason I'm thinking along the lines of making this table driven is that like right now, first of all, they look like a table. So we do have a couple where like I don't have named handlers for like numbers and parentheses yet, because that convention is like K_E would be lowercase e, K and uppercase E, K_uppercase E would be the handler for uppercase E, KC is Control E, and this is Alt E, and so on. The information you get from a terminal is not sophisticated enough to do Alt Shift E and Alt Control E. You might be able to do Alt Control E or CAE or something like that, but I have not done that yet. I haven't even tried that. So this is where we're at. We've got these definitions here. So this is like the default namespace with these key bindings. And then we've got another one down here for when you're in the editor. And it's annoying because they just basically delegate to this, all to the same object. Now that I say that, going back to copath, right? The copath of Y, I bet if this is the case, can I just pass that directly to coinsert? And I think I can. And I think then that for every one of these, where it's simply delegating to the control, I can just comment it out. Hang on though. Let's try it. But none of what I said is going to work. And that is because all of these keys, this is called a locative. It tells you not just which namespace to find the verb in, but it tells you which namespace should you execute in. So if I were to inherit like this and say this assigns something, that assignment is going to go into this namespace. So if Control D is going to try and modify a buffer to delete a character or something, it's going to expect that buffer to be in REPL keys. So I think this little side tangent was just a complete nonsense, right? Yeah, I'm typing now, nothing is happening. And the reason is something is happening, but names. So if I say names, names, REPL keys. Oh, maybe it's just here. Maybe it bubbles all the way up to the top. Yeah, B. Yes, that's what I was typing. So that member variable of the editor is being put into this top level namespace. So everything I just said is nonsense. You cannot do this. This is not valid. You have to do this. You have to have this underscore thing to tell it what namespace to use. Okay. So in that case, I think that's all I've changed. So git diff of jprez. I hope that's all changed. Yeah, let's do that. So jprez. All right, so that was a nice try, but not going to work. So let's go back to what I was saying about table driven. So once we get to this control in the jkvm repository where I have this UI framework, the edit widget. So the other part of that is that these key bindings are all defined here. And here, these are like the primitive methods, like backward, forward, beginning of line, back a character, delete character, end of 4 is go forward 1 character, BSP is backspace, kill to the end of line, swap 2 characters. And then here's the up arrow and the down arrow. And you notice they've all got this log in front of them. So this is the key that I press. This is the character that gets recorded in the macro language. And this is the verb that executes. And then once we've defined this, there is a completely separate place. So up in the update method of this object, we have the macro player, right? This is now a separate mapping that also maps the key to the function. So it's done twice, right? So if let's see, put this side by side. Here are the key bindings, and then here they are. They're done twice. So and we've got different orders, and who knows if these are the same. And like here we're talking about H, but where's H? Well, H is down here. Okay, then we're talking about 0. 0 is above it, and then we've got $. Where's $? End of line. Okay, do I even have a key? Yeah, it's way down here, and so on. They don't look like the same table, and so I think these are sorted by the actual key handler, and these are not sorted at all. And so I'd like to put these all in one table. And I guess I was thinking that since it's data, like maybe the focus swapping handler could somehow use that same table to figure out which key bindings needed to be in those REPL keys and out key namespaces. That's even then, that's a work in progress. It's not going to be the way I do this for all time, right? Like someday in the far future, this or some other program written with jkvm is going to be used by other people, and those people are going to want their own key bindings. You should be able to map the keys according to your own preferences. You should not be doing that by going in and editing the source code. So that should be a data structure. It should be data driven. The mapping between which key you press to which command it executes should be user configurable. Not just in this application, but in any application, right? Like you want the ability to override your key presses. The connection between what the macro records, like you don't want to record a macro, change your key bindings, and then play it back and it does something different. You want the macro to not record the key bindings, but the commands, right? So you want them decoupled. So these two things should have a one-to-one correspondence, but this side and this side should be user configurable. And then this side over here is the exact same one-to-one correspondence. It's redundant. What I would like to see is a table that maps these to these exactly once. So just a table that contains these two things. And then like here, we have 2 key bindings to the same thing, to the same command. I would think that then we want each key to be assigned to a macro, right? It might be a single character macro, like these, but maybe in the future you want something special. For example, like a swap is an Emacs concept where you press Control T and you can swap 2 characters and then advance the cursor. Whereas in Vim, so that the macro code was intended to follow the idea of the Vim key presses. And I think then in Vim, what you do is you like delete, you move forward, and then you paste, right? Oops, yeah, I don't know how to. There isn't a concept in Emacs of just deleting a single character. I guess you could do this and then that paste. You have to delete it with a selection. Whereas in Emacs, you would just press Control T, or you can even press Escape and then Control T, and that swaps 2 separate words, whatever Emacs considers a word. So maybe for down up here, you can say Escape T, and then down up becomes up down, or vice versa. So anyway, the point is that the single key binding, in order to emulate your favorite editor, might have to be several macro presses, which means that the macro language, because it's timed playback, we might want to evolve the macro language at some point to where you say something like this, put it in brackets. And so first of all, you would need to have like some kind of symbol that indicates a macro. And then you would say like mac is equal to BW0HX$L, whatever that does, executing all these keys in sequence. But then that would be a single key press in your language, right? In your favorite editor, maybe that is a single key press. And so you want that to be bound to a key press. And so then you don't want to record all of these things happening. You want to record that as if it were a single key press. So you don't want it to play this. You want it to play all in one step, in one tick or one beat of the playback. And likewise, that also solves the problem that sometimes you want, just for narrative purposes. For example, let's say I have a long string to type. I've just said that out loud. So now I'm going to type a long string to type. So that takes time. I guess it gives the viewer like a little bit of a pause, like a little bit of time to think, but you don't need to sit there and watch the presenter type 10 pages of text. So wouldn't it be nice if the comments can just appear on the screen? Because you can read a whole lot faster than the person can type, unless, at least the way I type. I'm sure there are people out there that type faster than people can read, especially if you're dealing with like foreign languages or non-native speakers. It would be nice if you could say 2 + 2 or whatever, and then that could happen in real time along with the spoken word, whereas the comments and so forth could appear just instantaneously. And that could be done by having this kind of like bracketing concept in the macro language. That's not what I want to work on today, but that kind of goes hand in hand with the idea of both defining macros as like named macros, so extending the language and providing some means of abstraction and naming, which implies that first there's some bracketing characters that allow you to package an entire thing as a single step. And probably you would want a different set of bracketing characters, maybe this or maybe even this or something like that, where, you know what the bracketing characters are, but that would play it back, but with each item being a separate key press at a tick in time, so that the update is operating on this concept of a tick. So a tick is every few seconds, fractions of a second, and you want the keys to be executed at that step. So you might want a batch of keys to be executed in one step. So you want both the ability to insert a bunch of text at once, or to basically run the macro without time on, to run it at infinite speed, and one to run with each invocation being a beat or a tick or whatever. And then once you've got that ability, it would be nice to give it a name. So I'm going to add all this to like macro language improvements. How about block syntax to run macro at max speed? Give blocks a name. And then, of course, once you've done that, you need the ability to invoke a named macro. Group syntax to record a macro. So character to invoke a named macro. Then we also need an end escape character to indicate the end of the name. Okay, so all of that is just stuff I want for the future. But today I want to try and make these table driven. So what would that mean? So key binding table. How about keys is equal to, and so now define this. Let's do it right. Noun define. Again, I almost think it's 2 tables. Like you've got like commands, macro commands would be K is on up, J is on down, B is backward. So when you press an ASCII character, that's going to be just like anything that's not accounted for, it would be in this. It's going to be outside of the table. But the idea is that this currently is the escape character for a quotation. So if you type ABC, that's going to be recorded as this, or possibly A with a space for the meaning that you took a long time to type it. That might change, but that's what it is right now. B is backwards, so K is on up, B is backwards. Let's just put all this in here. So just put all of it in here. B is backwards, W is forwards. So these are all based on Vim, and I may change that as well. But 0 to go to the beginning of the line, H to go backwards. This one I have 2 key bindings, so let's see. Well, it's not the key binding that matters. It's X is BSP, K is KEOL, T is swap. I'm just going to give me a second. I'm going to copy that. I want to put it back exactly how it was. GH, edit, revert buffer, and then I just want to only have my change be this table that I'm adding right now. So this isn't really the key binding table. This is the macro to command table, or macro to method table. And then we want the key to macro table. So keys is equal to noun define, and the same thing, but now we only handle the ASCII is the general purpose handler. So that's like anything that can't be handled by this table. Because I don't want to put every ASCII character into this. So we're only doing alt keys and control keys for the editor. So these then would be K, J, B, W, 0, H, X, $, L. And for this one, I need both control H is backspace and backspace key is backspace. K, clear to end of line, and then T is swap. Okay, so first I want to parse this table. So I'm going to run jprez, and now if I say keys _ red, I should get that table as a string. So this is a string that is 96 characters long. It is not a table. It just has new line characters in it. I'm going to call this keys like this so that I can just refer to it as keys now. I want to strip out any carriage return characters. That should be the same because this is a Linux system, and so there are no carriage returns in it. But this is the idiom for breaking by lines. Line feed and CR carriage return are just predefined constants in J. And then cut is a predefined function that cuts a string. I believe this should work. Yes. So now I have taken this table and converted it into a set of lines, each one in its own box. So a list of boxed strings. And then for each of those, I want to say cut without a left argument. Oh, yeah. So you know how I was saying everything can be both monadic and dyadic, take 1 or 2 arguments. So cut is two separate functions. This one says that if they're separated by this character right here. This is the definition character. So just as it was defining multi-line things, you can also put an actual verb on the right and a verb on the left, and these two things then give you the monadic and the dyadic definitions of the same verb. So here, the verb on the left is, this is the $:: is like a recursive function. Right? So it says whatever function I'm currently in, recurse. So $: refers to this entire line here. And then the and sign says bind this as the left argument. So if I call it without a left argument, then by default, it's going to stick a space character in as the left argument. And then the right-hand side is everything in parentheses, which says, so it's saying like this would be hello. That appends something to the front. So then the tilde appends it to the end. And then this right here says cut based on the last character, and then drop the last character as you do the cuts. And then this tells you what to do with those strings. So that is the cut. And then if you had like a bunch of these, you would have some empty boxes in there. And so then you can, the empty box is called a:. That's the name of the empty box as a constant. And then so this says remove that. So this is, if you have all of this in a string and you say remove the empty box, that's going to remove these two items. And if you say this does nothing because it's a verb, but you move it over here, now this gives you a way to put that value on the right-hand side. And so your pipeline goes off to the left. And so then you can remove these parentheses. And then just the fact that it's a verb, we call this y, and now that's a verb. And we can call this x. So this exclamation point could be x, and call it x. And so that's that. And then to make it even more compact, we can get rid of this. So we removed two characters, added one character. So we lost one character, add two characters. This is the cap function. And this is just a way to write this a little more tersely. Oh, I made a mistake somewhere. But what I mean to say is this. Oh, I see. I left out the @ sign. So bring it back here. Yeah. So you need to put an @ sign in between these to bind these two functions together. And there we go. So that's that. And then if you don't have the left argument, this is going to do something completely crazy. Yeah, it's just going to make a mess. And so you need to add the character to that side. And since you want it to be a parameter, you just give it a default value. And that's okay. Don't know why I'm deriving cuts in front of you, but there you go. Right, because this has no spaces, but then when you call it with the exclamation character that you really want to cut on, then it cuts. All right, so that's cuts. All right, so all that was a diversion, and I want to get back to the point where I'm cutting this. So then now I want to say cut each of these, which I've done, and then I think we can say cut every, and then if you say every, yeah, so the difference is there's a dot on one and not on the other. So every unboxes each one of these things and then cuts it. So unbox each string and cut it. So cut everyone is that, whereas cut each, this says you unbox, you cut, and then you undo the unbox, meaning you box it again, and which is why cut each does that. I don't want that. I don't want an extra layer of boxing. I just want cut every. So really, I don't even know why I use that. I should just write that because it's smaller and that's understandable to me and to other people who know J. Okay, this line right here is the code that's going to parse our table, except instead of keys, we want like Y keys. All right, so now we can parse in even the original keys of red or lead since they're the same. Okay, so now what? Now that we've parsed this table, I want to somehow generate this code. Oh, so first, so I also need to parse the other table. And that should be exactly the same thing, which what I call commands. Commands, yeah. All right, so I have two tables now. So we can say domain error, what? There we go. And now I want to take these two tables and use them to generate the key bindings. Let's see if we can just generate that code. So this is a bunch of assignments. So in order to generate this code, I need to merge those tables together. They happen to be in the same order right now, but that's not necessarily the case. Well, for example, they're slightly different because I've got two copies of this. All right, so let's take the commands table first. Oops, don't want each anymore. So we take the commands table. I'm going to just make a scratch Emacs buffer over here. So we call this what, parse? Or we'll call it table. And then we have table of commands. So let's give this a name. Maybe read table, rd table. And then when we run read table of commands.led, we get this. Okay. So now take the first item on each row. Every command in this table is a single character in the macro language. So this gives us the keys of the macro language. And then we can get it just as a single string right like that. I call them commands, so let's talk about command chars. Yeah, command chars is that. All right, so now we have command chars. So those are all the characters that are defined. And then now the actual commands, command verbs, would be take the second item. So one and take of each row of the read table of commands led. Let's call these, I'm going to use underscore, make it a little more readable. And in fact, we're going to say, so NB tables for macro language and key bindings. All right, so first read table is that, and then read table now undefined, and then now we just immediately get a table. Read table now undefined, and so then we don't need this anymore when we do our work. And then this then becomes commands, and this becomes commands. So here we're going to have, this is 1. So this is the same as 0 take of that, so you can just say the head. I'll do it for consistency. I'll do it like that. So we unbox the characters because they're just single characters, but here the strings all have different lengths, and so we need to keep them as boxed verbs. Also, the fact that it's a box string means you can invoke that verb directly. A box with a verb name in it is what you call a gerund, right? That's how you turn a verb into a noun that you can pass around to other functions, and thus create higher order functions. So now we can run these two lines of code, oops, over here. So command chars, oops, because we want commands to be commands of red, or any one of them, command chars. Then we have to run, oops, okay, let's run that again. And now command chars is the text and command verbs is that. So I need this line to use on the scratch buffer, or when I run this code. So key commands is going to be the string that is in the second column of keys. So let's see what that does. Does that? So that's what I want. So we're going to extract that second column, and then I guess key press maybe is the first column. So we look at that, we see that. So we want to do a join now, right? Let's see how that works. We say key press. I'm going to make a consolidated table now. So let's do key press, key commands, and command chars, and then command verbs. I want all these to be vertical. So so then I can just say each, right? Oops, command verbs. What's wrong? What's wrong? We need an extra layer of boxing on that one. There we go. Okay, so that's what I want. So now I want to use these two as a join, like in SQL. And I want to map these to these. I feel like I've done this, and I have a library ready to go, waiting for this, but it should be easy enough to figure out. It's like the only difference really is that between these two, like this is a direct mapping, except for the X is doubled. But you can't rely on that. Let's make it interesting. Sort lines, and then this line as well. So we'll alphabetize both tables. So let's exit this. Or we don't even have to exit. We can just say load scratch.ijs. And so now when we run this, oh, we didn't, so we got to reload. Hang on. This is a known bug that I keep putting off, and then it keeps biting me and breaking things up. And the window just needs to be bigger for this to run, otherwise it crashes. Okay, so load scratch.ijs. And then when we run this, we get this. All right, so now they're out of order, and it should make our life a little more interesting. All right, so key commands and command chars are the same. So we can say index of key commands, index of each. Oh, I'm sorry, not key commands. Key, yeah, what is key commands? Key commands. What am I missing? Key commands. If I ask for the command char index of J, commands chars. Command chars. Sorry, that's what I'm doing. Command chars. There we go. Index of key commands. There we go. All right, what does that tell me? That's telling me for each one. So command chars of, so if I say 7 take of, that's J, and then key commands 0, the very first item. So I'm looking at this item right here. So I said whatever this is should be a J, right? So in other words, I'm mapping each item of key commands, and I'm saying where does that item appear in command characters. So find the index of each key command in the command characters. Now from that I have this mapping. So now I want to use those numbers. Right, so you can see here that the number goes on the left. So I want the number. I have the numbers on the right. So I'm swapping them. So I'm using this to swap the numbers on the right. And I'm going to use those indices to look up the value of the command verb. And then if I say key press, that should give me my mapping. So this whole line is mapping the key press to the appropriate command. So that's like how you do a join in an array language. So this is the expression to map keys to commands. And so now if I want to generate this chunk of code, it won't be this chunk of code exactly. It'll be, because of the duplicate here, I want to generate this chunk of code without this. Whatever, it doesn't matter what T does in bin. So I want to generate this chunk of code, not this, but these definitely are in it. So this chunk of, and if I sort lines here, yeah, this should be the same, because I'm sorting by key press, so this should be the same sequence. So let's move this over again, and let's put them side by side, and then swap them to edit.ijs. Put these at the top, maybe right here. All right, so we've got arrow down, arrow up, backspace, B is, oh yeah, backward, forward, A is BOL. Yeah, these are the same. All right, so we managed to generate that table, but we don't have this middle key, this middle character here. So to generate that code, I also need to add that extra column in there. So command verbs gives me that, and so I have command verbs of command chars, and then I'm going to also have the command chars, right? This is not command verb. This is a command verb. I'm using the index generator by this expression, so I also want to now rearrange the characters themselves based on that ordering, and you need the and sign. So now we've got, once you put the and sign there, this is all one verb, this is a verb, and this is a verb, and so that makes a fork. And so this value gets fed into both sides, and then the results of both of these get fed into the stitch command. And so we wind up with a new column here. But once you add the and sign, you don't need this thing anymore, because that would switch the things around. What's wrong? Is this also already a conjunction? No. And if I do that, why is that a domain error? Oh, because it's like this. There we go. Okay. Sorry. All right, so let's go back to about here, and we really want it. You want it here. Sorry. All right. So I did want the tilde. I was just so we want it on the right hand side. All right. So now, so extract from verbs and chars based on these indices, and then okay, but then we need to box each one of these, and then put them side by side with the command verbs. There we go. And I had that twice. There we go. Okay, not so hard when you just sometimes that happens a bit, and it's a little hard to see the character. That's why I want like syntax highlighting in my REPL, and I want the ability to like be a little smarter about like tokens and stuff. So that's all coming in the future. All right, so then now we can just go ahead and add keyprez back in here, and that's our table. Okay, I guess in the code that it's oops, hang on. In the code they're in the opposite order. So we swap those two columns, but really we could just swap them in the actual code. There's no reason why it needs to be like that. Like that. And there we go. That's my expression. Okay, so now given that table, we should just be able to generate this. So let's call that just T for temp. And then now we have T. And what can we do with T? Well, let's say, switch back to this. So we want, so I'm trying to make a template, right? So I want to do like something like that. Hello, but I want it to be hello world. And then like that. And then, yeah, that's what I want. All right, so now let's take the first item of T. We don't have enough delimiters, so let's put an X here. All right, so we can say equals K arrow down, trying to generate this line. So we're going to say is equals to log at, there's the thing, okay. And we're going to say that's the strings are single quotes limited, and then we've got double single quote inside to escape that string, and then a space on down J, and then at the end we're going to have a line feed, and then we're going to do this to each of T, but not each. We're going to do it at rank 1 of T. And then put all those together into a single string. That's weird. Yeah, okay, I guess it, yeah. Oh, I see. Hang on. Yeah, so it's going to make it, each one of those is the same length. So if we say box length 1 and then draw it like that, you can't tell, but there's spaces on each of the end of these. So we don't want that. It doesn't really matter because we're just going to execute that. And so now what happens if we execute this? So kc of T is what? Log at T swap. Okay, so erase kc of T, and now it's not found, and then we run this, and then kc of T is that. So that did that definition. So that generated that code for us. All right, so this line right here generates this table for us. So extract columns, those tables, of those above tables. And then this would just show the tables. So that's not important. So expression to map, right? So this is the only one we wanted. So now for each key name, so we're basically defining the keyword handlers. Okay, so now if I delete this, we'll save it over here just for safekeeping, even though it's in version control. We'll save it. And I think that the idea is that we've now defined the table. We've defined this table. This can be outside of that scope. This is like catch-all keyword handling for inserting normal keys. So example for the command character would be, we'll do them in this order. So keypress can be example would be the box string K, control C, E. So then here, the command character is the end of line string. The command verb is K, EOL in a box. And so that gives us the mapping. And then, so then we'll give the exact code that we're doing. KCE is equal to log at E, or log at $ at KEOL, which should have been the exact, yeah, except I'm talking about the E character and then confusing what they do. E goes to end of line. That's what I wanted. Yeah, okay. Now I'm double L, it's EOL. So that's either one of those fixes would be, so EX, right. There we go. All right, so we've generated that table, and now we've removed this code. So let's go back here, and I believe now it should work. Hello world. See, go to the start line, delete these, and so on. All right, so now you notice or you don't notice it, but I notice it when I hit. So Alt D, I guess I don't. So Alt D or Escape D is not bound to anything yet. But let's see, I have a whole list of keys to add tomorrow. But what I was getting at is now I have to define it here. But even though we've defined it here, we still have some duplication because it's also defined in the update method here when we do the player. So that still needs to be table driven. And then in jprez itself, we have this redundancy here where we're copying it again. But I think now that we can generate these little templates, I think that we can maybe make a function that we just give it a template that we want to execute. And then for each key binding, we'll get that triple on the line. And then we can just say, like, how do you want it to look? And just pass in a template and generate all this code. And then so we would generate it. And then like here where it's Control M or the Enter key does something special, that would move to the bottom down here. And the rest will be generated. So like this will be generated, this will be generated. And so we'll have this nice mapping like that. And then these two will be at the end. So NB, tomorrow we will generate this based on our tables. And that way I can review the code and make sure, summarize what we did today again and go over it. So this is not done, but this is in progress. So let's say Control M, left. So regems, this is 21. Yeah, I really like this. I like doing this kind of like table-driven stuff in J. It's always nice when you can make your code data-driven, and J is especially good at it, but you have to write these little parsers and whatnot. And I think maybe what I want is to have a standard set of these for parsing and dealing with table-driven code like that. Okay, in fact, I do have some code like that, so maybe I'll look at that tomorrow and see if I can incorporate that into a library that, or an add-on or whatever. So let's go down to Git, and let's see what we did today. All right, gd of UI edit.ijs. All right, so we actually introduced a lot of lines, but I think the code, if it's not smaller, it's at least it's data-driven. Probably was a lot more, this was obviously simpler, but now it's data-driven and relational, and basically made our own little relational database here. So UI edit, make, start on, table-driven key bindings. I'm not going to check that in because it's not done. GD backlog. And then tomorrow we will finish this and make the macros table-driven using the same scheme and so on. I'm going to have to think about that a little bit because for the macros in edit.js, they're inside of a case statement. So maybe I can just generate this and evaluate it. Can you evaluate a case statement like that? I don't know. I don't know if you can do a multi-line do like that. So we might have to think about it. But also, with the exception of this line, every one of these is simply a name followed by invoking that. And so we can probably use invoke gerund. So I guess this conjunction can be used to evaluate the code. So we can use this to look up the verb name, and then we can use the boxed verb name. So you can have a boxed verb name, and then I think 0 turns it into an actual verb, and then you execute it like that. So I think we can replace all of that with this, where the verb name is looked up from those tables. So we'll see. We'll try that tomorrow. That's it for today. Thank you so much for watching, and I hope to see you soon.